Division is going to be exactly the same, so we're going to factor everything first. But the extra step is I have to flip-flop that second fraction. Okay, so here's our second example. I have to flip-flop the second fraction because it's a division problem. That's how we divide regular fractions, although we don't do that very much anymore. All right, so here's my problem. 3 plus 2x minus x squared. Okay. So we're going to start these by looking again at if they have anything in common first of all, and factoring that out to make it easier for us. So let's see. Let's look at the top left again. We'll start with that. I'm going to not use the generic rectangle, if that's all right. I'm going to show you again how to do that without just kind of by guessing around. The reason for that is this 2, there's only 2 numbers that multiply to 2. It's got to be a 2 and a 1. Okay. So the next part I need to decide is things that can multiply to 15. Well, that could be 3 and 5, 1 and 15, and that's it. So I just have to figure out what combination of those is going to work. I also know this symbol means I need one of each, one positive and one negative. So I'm going to try to figure out where they should go first and then decide on the symbols. That's just the way I like to do that. So if I use the 3 and the 5, that's going to get me maybe closer to a 1 than the 15 and the 1. So let's see what happens. Let's put the 5 here and the 3 here. Not even worrying about the negative signs for right now. So if I multiply the insides together, this is going to give me 3x. Outsides together, that's going to give me a 10x. Okay? If I either add or subtract those, not going to get me to this -1 where I'm trying to get. So that's not going to be the right way to set up those numbers. All right, let's try switching the order. Put the 5 in this first one and the 3 in this one. Again, I'm going to multiply the insides together. So I get 5x here. This one I get a 6x. If I do something with those, I can possibly get a -1 if this 6x is negative. Okay, so to do that, I'm going to make this 3 be negative and the 5 be positive. So I'm going to erase that here. It's always good to just recheck, maybe in your head to recheck that you get the same thing you're supposed to start with. So that's that first fraction of the numerator. And now we're going to look at the bottom of that fraction. Look at what they have in common. Okay, they're both divisible by 5, and they both have an x. So I'm going to pull that out. So left over we'll have 5x squared divided by 5x is just 1x. And then 10x divided by 5x is just a 2, positive 2 left over. All right? Now I need to flip-flop my fraction. This fraction is going to get switched upside down because it's a division problem. Okay? So now I'm going to start working with this one. I'm going to start factoring this one next. All right, let's rewrite. What would that be if I divided everything by 5? They all have 5s in common. So I'm going to write 5 parentheses and write what would be left. So this would be an x squared plus 2x plus 1. Now I need to factor this further, okay? So let's see what we can do with that. I'm just going to write it somewhere for now, and then I'll just erase this part. So I can factor this, again, without my rectangle, because there's just a 1x squared in the front. That's pretty easy. It's going to be an x and an x. Things that multiply to 1, only 1 and 1, and they're going to both be positives. Okay, this is actually a perfect square trinomial. So I'm just going to erase this part on the inside and replace it with the x plus 1 and x plus 1. You could write x plus 1 squared if you wanted to. All right, there we go. Again, that was the denominator of the second fraction because we had to flip it upside down since it's a division problem. So now I'm going to look at this one. Let's maybe rewrite this first. That might be more helpful. I'm going to just change the order of it and write the x squared part first. So it's negative x squared, keep this 2x here, and then keep that as a positive 3. So now I'm going to try to factor that quantity, okay? Because normally in standard form we have the highest exponent comes on the left. So things that multiply to a negative x squared, one's going to be negative and one's going to be positive. Now you could multiply all of these by -1 if you want first, but I'm going to worry about that at the end. Things that multiply to 3 are going to be 3 and 1. And I need them to both be positive. So let's see, does this work? This gives me a -3, gives me a +1. So I'm going to switch my location of those numbers. This gives me a +3, gives me a -1. So together they add to be a +2, which is what I wanted. So everything's factored now. I just need to look for what I can cancel. So let's switch pens here. I have an x plus 1 and an x plus 1 exactly on top of each other. But remember, I can look diagonal too. So I have, let's see, I have a 5 and this 5. I can cross those out. Okay. But now I have an x and a minus 3, but I have negative x plus 3. Those are just a tiny bit opposite of what they should be. So here's where I'm going to pull out the negative 1, which you may have done earlier. If you multiplied all this by a negative 1, all these signs would be opposite, and you should have a negative 1 in front of everything. But if I notice it at the end, they're very similar but opposite symbols. If I divide a negative 1 by everything, and I pull that out in the front, just like when you factored out this 5, okay? I need to get back to negative x plus 3, but I need to change this. So if I were to remultiply these, it's not negative x anymore, it's positive x. So now this needs to be a plus x. If I remultiply this, I get a negative 3, and that's not what I want to get. So I need to change that to a negative. Now this is what I started with, so now it's still equivalent to that if I were to distribute the negative 1, okay? So that's why we pulled out that negative 1. To change each of these symbols. Now these are exactly the same. I can cross out the x minus 3 and the x minus 3. So let's write what's left over. That's about, looks like all we can do here. So we have 2x plus 5 on the top, and also this x plus 1 on the top. Okay. On the bottom, it's looking like we have a negative 1 and an x, and then this quantity. So I'm just going to put these together, the negative 1 and the x, so that multiplies to negative 1x. And then I have this x plus 2 quantity. So nothing else reduces, nothing can be simplified further here, okay? Because I need to make sure that they had to be exactly the same. Right? This x and this x, I cannot cross those out because they're not exactly the same x plus 1 quantity and x plus 1 quantity down there. So that's our solution. And let's also write what x is not allowed to equal, which this one with division is a little bit more complicated. So let's go back to before we cross anything out, and each of the denominators, I'm going to set those equal to 0. Okay, remember what this was, the signs were backwards before we took out the negative 1. So I'm going to set this equal to 0. If I set 5x equal to 0, I'll get a 0. So we don't want that. If I set x minus 2 equal to 0 and solve, I'd get a negative 2. Okay. This was opposite, so let me write that over here. It was negative x plus 3. That's what this was. Okay, so if I set that quantity equal to 0, I'm going to get a positive 3, and I don't want that. I don't want x to equal positive 3. Actually, I get the same thing if you use the factored out version too, so that's good to know. You can just use what you have there. If I set x plus 1 equal to 0, I'll get a negative 1. Okay, so we have those ones so far from the denominator. However, this really wasn't the denominator to begin with. This part was, right? We had to flip that fraction upside down. So I need to set each of these equal to 0 as well. Now, luckily in our case, it's already accounted for down here, right? If I set x plus 1 equal to 0, I already would get negative 1. But so to make sure to check the top of the dividing problems, because that was originally the denominator to begin with. So we don't want that to be worth 0 either, because then I get an error from the very beginning. Most of the time we're not going to ask you to find these restricted values when it's division, just because it's a little bit more involved, but that's what you should be able to do that if you needed to.